separately derived system is permitted to supply both non-isolated receptacles and isolated ground receptacles. There is no restriction limiting it solely to isolated ground receptacles. To understand this better, let's define what a separately derived system is. According to the National Electrical Code, a separately derived system is an electrical source, other than a service, that has no direct electrical connection to the service conductors. Examples of separately derived systems include generators, transformers, and solar inverters when operating in off-grid mode. The key characteristic is the lack of a direct electrical bond between the source and the main service. This isolation creates a new electrical system with its own grounding requirements. Now, let's discuss non-isolated receptacles. These are standard electrical outlets where the grounding terminal is connected to the equipment grounding conductor, which in turn is connected to the neutral conductor at the service entrance or the separately derived system's grounding point. This connection provides a path for fault current to flow back to the source, allowing the circuit breaker or fuse to trip and to energize the circuit in the event of a ground fault. Next, let's discuss isolated ground receptacles. These receptacles have a grounding terminal that is isolated from the metal frame of the receptacle and the equipment grounding conductor. An insulated grounding conductor runs directly from the isolated ground receptacle to the grounding point of the separately derived system, or the service equipment grounding point. The purpose of an isolated ground is to minimize electrical noise and interference. This is especially useful for sensitive electronic equipment like computers, audio equipment, and laboratory instruments. By isolating the ground, any noise present in the building's grounding system is less likely to affect the performance of the connected equipment. When using a separately derived system, the grounding requirements are outlined in Article 250.30 of the National Electrical Code. This section specifies how to ground the separately derived system, ensuring proper fault clearing and minimizing voltage rise during fault conditions. The grounding electrode conductor is connected to a grounding electrode system, which can include metal water pipes, building steel, or ground rods. The size of the grounding electrode conductor is determined by Table 250.66, based on the size of the ungrounded conductors of the separately derived system. In addition to grounding the system, it is important to bond the metal enclosures and raceways to the grounding system. This ensures that all metal parts are at the same potential, minimizing the risk of electric shock. Bonding jumpers are used to connect metal enclosures to the equipment grounding conductor. Now let's consider the common misconceptions. Some people believe that a separately derived system should only supply isolated ground receptacles. This is not true. The code permits the use of both non-isolated and isolated ground receptacles in the same separately derived system. The choice of which type of receptacle to use depends on the specific application and the needs of the equipment being powered. For example, general-purpose lighting and appliances can be connected to non-isolated receptacles, while sensitive electronic equipment may benefit from isolated ground receptacles. When installing isolated ground receptacles, it is important to follow the code requirements carefully. This includes using an insulated grounding conductor and ensuring that the receptacle is properly labeled. The isolated grounding conductor should not be connected to the metal box containing the receptacle. It should run directly back to the grounding point of the separately derived system. The green-colored screw terminal on the isolated ground receptacle is used for the connection of the insulated grounding conductor. It is important to distinguish between an isolated ground receptacle and a standard receptacle. Isolated ground receptacles are typically identified by an orange triangle on the face of the receptacle. This helps to prevent accidental miswiring and ensures that the isolated ground is properly maintained. Now let's discuss the benefits of using a separately derived system. Separately derived systems offer several advantages, including improved power quality, increased reliability, and enhanced safety. By isolating the electrical system from the main service, separately derived systems can reduce the impact of voltage fluctuations, harmonics, and other power quality issues. This can improve the performance and lifespan of sensitive electronic equipment. Separately derived systems can also provide backup power in the event of a utility outage. For example, a generator can be used as a separately derived system to power essential loads during a power failure. This can be critical for businesses and organizations that need to maintain operations during emergencies. Safety is another important benefit of separately derived systems. By properly grounding the system, the risk of electric shock is minimized. The equipment grounding conductor provides a low impedance path for fault current to flow back to the source, allowing the circuit breaker or fuse to trip quickly and to energize the circuit. Now let's talk about the common applications. Separately derived systems are used in a wide range of applications, including hospitals, data centers, industrial plants, and commercial buildings. In hospitals, separately derived systems are used to power critical medical equipment, ensuring that it remains operational during power outages. In data centers, separately derived systems are used to provide clean and reliable power to servers and other IT equipment. In industrial plants, separately derived systems are used to power machinery and equipment that require stable and consistent power. In commercial buildings, separately derived systems are used to power lighting, HVAC systems, and other essential loads. When designing a separately derived system, it is important to consider the load requirements, the available space, and the budget. The size of the transformer or generator should be based on the total load that will be connected to the system. The location of the separately derived system should be chosen carefully to minimize noise and vibration. The cost of the system should be weighed against the benefits it provides, such as improved power quality and increased reliability. Now let's talk about some code requirements. Article 450 of the National Electrical Code covers transformers, including those used in separately derived systems. This article specifies the installation requirements for transformers, including ventilation, overcurrent protection, and grounding. Article 700 of the National Electrical Code covers emergency systems, which often include separately derived systems powered by generators. This article specifies the requirements for emergency power systems, including the size and type of generator, the transfer switch, and the distribution system. Article 701 of the National Electrical Code covers legally required standby systems, which are similar to emergency systems but are not required by law. These systems often include separately derived systems powered by generators. Article 702 of the National Electrical Code covers optional standby systems which are not required by law or by any other authority. These systems can include separately derived systems powered by generators or other sources. When installing a separately derived system, it is important to comply with all applicable codes and standards. This will ensure that the system is safe, reliable, and performs as intended. Now let's discuss some common troubleshooting issues. One common issue is voltage drop. Voltage drop occurs when the voltage at the load is lower than the voltage at the source. This can be caused by undersized conductors, long circuit runs, or excessive load. To minimize voltage drop, it is important to use appropriately sized conductors and to keep circuit runs as short as possible. Another common issue is grounding problems. Grounding problems can cause a variety of issues, including electrical noise, equipment malfunction, and electric shock. To prevent grounding problems, it is important to properly ground the separately derived system and to ensure that all metal enclosures and raceways are bonded to the grounding system. Another common issue is overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overload and short circuits. If an overcurrent protection device trips frequently, it could indicate a problem with the circuit, such as an overload or a short circuit. It is important to investigate the cause of the tripping and to correct the problem before resetting the overcurrent protection device. Another common issue is harmonic distortion. Harmonic distortion is a type of power quality disturbance that can cause a variety of problems, including equipment malfunction, overheating, and increased energy consumption. To minimize harmonic distortion, it is important to use equipment that is designed to minimize harmonics and to install harmonic filters if necessary. In summary, a separately derived system is permitted to supply both non-isolated receptacles and isolated ground receptacles. The choice of which type of receptacle to use depends on the specific application and the needs of the equipment being powered. It is important to follow the code requirements carefully when installing a separately derived system to ensure that it is safe, reliable, and performs as intended. By understanding the principles of separately derived systems and following the code requirements, you can ensure that your electrical system is safe, reliable, and efficient. Firstly, understand what a separately derived system is. Secondly, recognize the differences between isolated and non-isolated receptacles. Thirdly, adhere to NEC Article 250.30 for grounding requirements. Fourthly, ensure proper bonding of metal enclosures. Fifthly, be aware of common misconceptions regarding system limitations. Sixthly, understand the benefits of using separately derived systems. Seventhly, consider load requirements and system design. Eighthly, comply with all relevant codes and standards. Ninthly, troubleshoot common issues such as voltage drop and grounding problems. Tenthly, maintain the system regularly for optimal performance. Now let's get into specific scenarios. Let's say there is a data center needing a clean power supply for its sensitive servers. In this instance, a separately derived system with isolated ground receptacles would be the optimal solution. The isolated ground minimizes electrical noise, protecting the servers from data corruption or malfunctions. In contrast, consider a workshop with power tools. Here, a separately derived system can supply non-isolated receptacles for general-purpose tools, and isolated ground receptacles for sensitive equipment like oscilloscopes or computers used for machine control. Both types of receptacles can coexist in the same separately derived system, tailored to the equipment's needs. It is crucial to remember that the size of the transformer or generator in the separately derived system must be adequate for the total load connected to it. An undersized system can lead to voltage drops and equipment malfunctions. Also, the location of the system is important. It should be easily accessible for maintenance, but also protected from environmental factors like moisture or excessive heat. The grounding electrode system should be properly installed and regularly inspected to ensure its effectiveness. Ground rods, metal water pipes, or building steel can serve as grounding electrodes, but their suitability should be assessed by a qualified electrician. Regular inspections and maintenance are critical for the long-term reliability of the separately derived system. This includes checking the grounding connections, inspecting the wiring for damage, and testing the overcurrent protection devices. Any signs of wear or damage should be addressed promptly to prevent potential hazards. Furthermore, when dealing with sensitive electronic equipment, power quality is paramount. Harmonics, voltage transients, and other power disturbances can negatively impact performance and lifespan. Consider using power conditioning equipment like surge suppressors, line filters, or uninterruptible power supplies to further enhance power quality. It is also important to consult with a qualified electrical engineer or contractor when designing and installing a separately derived system. They can assess the specific needs of the application and ensure that the system is properly designed, installed, and maintained. Furthermore, understanding the specific requirements of the local electrical codes and regulations is essential for compliance and safety. Local authorities may have additional requirements beyond the National Electrical Code, and it is crucial to adhere to these requirements. Lastly, continuous education and training are crucial for electricians and other professionals working with separately derived systems. The electrical code is constantly evolving, and staying up to date with the latest changes is essential for ensuring safety and compliance. Attending seminars, workshops, and other training events can help professionals stay informed and improve their skills. By following these guidelines and best practices, you can ensure that your separately derived system provides reliable, safe, and high-quality power for your specific application. The key takeaway is that the system's flexibility allows for both isolated and non-isolated receptacles, catering to a wide range of electrical needs.